Hey, Nathan here. Welcome back to another video for MonoGame. In this video, we are going to discuss the implementation of vector reflection. The last video I released, we discussed the algorithm and the mathematics involved with vector reflection. In this video, we are going to discuss the coding implementation of that. I'm going to release another video for the video game mathematics series that covers it's not really mathematics, it's more of an algorithm, and it will discuss why the algorithm is the way it is when we test to see if our rectangular collision detection, if we test to see if it's on the left side, right side, top side, or bottom side, how we get that to work. So for now, I'm just going to copy the code that I have created for my PGL2D library and paste that in this video. And I'll discuss it a little bit on that. So this is the previous tutorial's result. This is the transformed per pixel collision sample. I've just added it on here and changed the namespaces around. I've also changed it to where I'm giving you a ball, just a little circle, and I have provided a paddle as well. And this is going to be included in my paddles video. The reason I'm doing this is so you can see what it looks like without having to see a giant triangle. Okay, the first thing we want to do is let's add our collision code here. So let's right click our project and let's go to add new class. And you can't see that, but I'm just adding a new class. Now I'm going to call this collision. It's going to be a public static class collision. And like I said, I'm just going to copy and paste what I have already and just put it in here. I'll enter to add all the namespaces. Okay. So the first thing, we just passed rectangular collision detection with two sprites. Then it returns rectangular collision detection with those rectangles, which just returns this here. Just A dot intersects B. The next one, if you want to get the normal, it's similar, but it has all this extra code here. So I worked on an algorithm. When two objects collide, we need to get the delta value, the A position minus B position. The delta position values between those two objects. So that gives us delta. Then I get the absolute value of x and y. So the right side, if delta.x, if object B is to the right of object A, then we know it's on the right side. But we also need to test if the absolute value of the y, the delta y, is less than half the height of the target object. We also need to check to see if the velocity is negative, which means our object is traveling to the left. This is not really necessary, but this is an additional check. If the velocity is moving to the left and then it hits our object, we know it's going to hit on the right side. There is no way, unless we're moving an object way too fast for the collision detection to check, that will be another video we'll discuss. There's no way an object traveling to the right will hit another object on the right side. It's going to pass through it on the left side. There is no way an object traveling in the positive x direction will hit another object on the right side. It will first hit it on the left side. And as I mentioned in a later video, we will discuss objects that are moving much faster. One game loop, it's not even close to the object. The other game loop, it is completely past the object. A bullet, for example. You want a bullet to travel so fast that it might avoid the collision detection code. So in that case, there's a few things we can do to get around that, but that will be in a later video. So this velocity check is not really necessary, but it is an additional check, a requirement for that side to be hit. So it does not like that, so let's go to the sprite and see what's going on. So we do have a velocity. It's read-only. Let's change that right now, because our velocity will change when we reflect. These are public getters. So we do not have a public getter for that. That is a private field. Private vector2 underscore velocity. So let's add a public getter for that. Public vector2 velocity equals greater than underscore velocity. Okay. Now I press save, Control S. Now I have 0 errors, 0 warnings, and 0 messages. Our collision code is now happy. And if you're not sure what this is, stay tuned for the next video game mathematics video, and I will discuss that. Let's change the collision in the sprite. So that's done. Now let's go to the sprite and we'll update the collision code there. So we're not doing per pixel collision in this video. Let's collapse this method and delete that. And then let's delete that. Actually, let's delete everything after the... We have a var intersects here is equal to all this code. Let's delete everything except the semicolon. So we just have var intersects equal semicolon. That is in the collision method. So the way that this works, we need two things. We need to check to see if the collision has occurred, which we'll get. This is actually a bool. It's var, but it's a bool. So if an intersection did occur, we also need to get a normal. The way that vector reflection works is that you reflect the vector across the normal. And that normal is based on the collision point. So vector 2 normal, and that's going to be a vector 2. So we have a collision class. It's a public static class. So we have some collision method in there that we can get rectangular collision. Source. What we want to reflect is A, this. What we want to be reflected by is the target. And our normal is what we will receive, out normal. So that returns a true or false if the collision has occurred. It will also return a normal. These two lines are fine. You can keep those. But we need to add one more thing here. If intersects underscore velocity is equal to underscore velocity dot reflect normal. Now it does not like that because I do not have a method for that in a vector 2. XNA and MonoGame have their built-in reflect method. If you do vector 2.reflect, they do have a built-in method to handle reflection. I do not like the mathematics behind how they handle the reflection. I like to understand how it's reflected and maybe change things up on my own if I want to. You can use that vector 2.reflect if you want. And remember, it needs a vector and it needs a normal. So we already satisfy those two. Underscore velocity and normal. So you can use that if you want to. I like to use the mathematics I discussed in the video for that. So what I'm going to do is I'm going to build an extension method for the vector2. So I'm going to right click my project and go to add class vector2ex. It's going to be public static class vector2ex, and the method is just going to be public static vector2 reflect. This vector2 for the velocity or vector, I'm just going to call it v, doesn't have to be velocity, and then vector2 n for the normal. And then if you've watched my video game mathematics video that discusses this, I'm just going to return v plus vector2.multiply n comma 2 times vector2 dot negative v comma n. If you're not sure what this means, go watch the game math video that I discuss how to get the algorithm for this. This is the final result from that video. We did all these calculations and we got that mathematics result. And I just converted that to programming code where we do vector2.multiply and vector2.dot. But in the actual video, it's the dot product. It's not, I don't have this vector2.dot in that video. It's just the mathematics involved with that. I just converted this to the MonoGame code for that. So that is how to get the reflection method for our algorithm. Again, you can use the built-in vector2.reflect. You can use that built-in one. Completely up to you. Now this is the extension. If you hover over that, you see it says extension. So now we know we're calling my code. Okay, so that is the sprite. Now let's take a look at the constructor. Let's see if that is correct. Position, speed, angle, rotation speed, scale, and bounds. That is correct. Now let's look at the debug sprite. Position, rectangle color, speed, angle, rotation speed, scale, bounds. That is correct. Everything is correct. Okay. So let's go to game 1 and let's change that to our paddle and our ball. So we have a private debug sprite underscore arrow and underscore arrow 2. You can get rid of those and change that to underscore ball and underscore paddle. And you can delete the initializers here. And I'm going to go over here. I'm going to adjust my source here. Give me 1 second. Okay. Underscore ball is equal to new debug sprite. Alright, the position is going to start at the left side of the screen, and it's going to be half of the height, and then we're going to subtract some random amount just to push it up towards the top of the screen a little bit. So new vector2, 0, left side of the screen, open parentheses, underscore graphics, dot graphics device, dot viewport, dot height, divided by 2.0f, that's the center of our height. Then we're going to subtract it by, let's say, 160. Color.white. Color.white means whatever you see in the image editor or whenever you open it up in Windows itself, that same look of that sprite is going to be what we see in the code. So color.white, and then 100, that's going to be our speed. I want the ball to travel a little bit fast. We're going to offset the rotation, math helper dot 2 radians. I want it to start at like 10 degrees. Now I want the ball to rotate over time as it's traveling towards the paddle. So what I'm going to do, I want it to rotate 360 degrees every second. So that is math helper dot 2 pi. Yeah. 1, that is for the scale. And our bounds is just going to be our underscore game dimensions. I want it to be bounded to the game window. Underscore paddle is equal to new debug sprite. It's going to be on the right side of the screen, but I'm going to push it to the left a little bit. New vector 2 underscore graphics dot graphics device dot viewport dot width minus 150 comma underscore graphics dot graphics device dot viewport dot height divided by 2.0 f. I want it to be centered, but I'm not going to adjust it any further. Color dot white, that's fine. This paddle is not going to move, so I'm not going to restrict it to the bounds. It's just going to stay where it is. Load content, underscore arrow 1, change that to underscore ball. So underscore ball dot load content. The asset name is just going to be ball. Underscore arrow 2, change that to paddle. And then the asset name is just going to be paddle. Alright, the unload content, underscore arrow 1, that's underscore ball. Underscore arrow 2, that's underscore paddle. Alright, in the update method, I'm going to delete those 3 lines that it has issues with, and I'm going to set underscore ball dot update game time. And then I'm going to check the collision, underscore ball dot collision underscore paddle. The paddle is not going to move, so I'm not going to call the update method on paddle. And then the draw, in the first if condition, delete everything in those parentheses, and let's just set underscore ball dot collided. Alright, in the actual drawing, where we have underscore arrow 1 dot draw, change that to underscore ball dot draw, and underscore arrow 2, change that to underscore paddle. Alright, we have no errors, no warnings, and no messages. Let's press F5 and let's see what happens. It stopped working. It's the first time I've had that happen with Visual Studio 2015. So that ball is traveling towards the paddle. Hopefully our reflection will work. There we go. That reflected the velocity. For some reason that crashed. As you see on the right side, I don't have any diagnostic tools. So let's try this. Let's go to build, clean solution, build, rebuild, F5. Yeah, Visual Studio just probably needs to be restarted. I won't worry about that. So that is vector reflection. I will release another video game mathematics video that will discuss the algorithm on why these are valid. And again, I just included the velocity for an additional check. Alright, so I hope you enjoyed this video. I will provide the collision code so you don't have to write down what you see and pause the video and write down this. And it's even going past the screen here, so I'll provide this code for you. And then that's not just the bottom right, that's all corners. So I'll provide this for you. I'll give you the new pictures that you can use, the ball and then the paddle. and it'll provide the previous sample, so that will give you a good starting point. So I hope you enjoyed this video. Stay tuned for the next one. Let me bring that up here. The next one will be a sprite sheet. So stay tuned for that. Thanks for watching.